Ever heard the saying, if you want to learn physics, don't start with Newton? It's a bit of a provocative statement, isn't it? After all, he's the guy who gave us the laws of motion and universal gravitation. He's the very foundation of classical mechanics. So, how could he possibly be a bad place to start? The answer, as with most things in life, is that it's complicated. And it's a question that gets right to the heart of how we learn, how science progresses, and the difference between historical understanding and modern pedagogical methods. Today, we're going to dive into this debate and explore whether Sir Isaac Newton is truly a beginner's worst nightmare, or if there's still something to be gained from his original work. Let's begin by setting the stage. When we talk about starting with Newton, we're not just talking about his laws of motion, which are taught in every high school physics class. We're talking about his magnum opus, his masterpiece, the book that single-handedly changed the world, Philosophiae Naturalis Principia Mathematica, or just the Principia for short. This book, published in 1687, is one of the most important scientific works ever written. In it, Newton lays out his 3 laws of motion and his law of universal gravitation. He uses these principles to explain everything from the orbits of planets to the tides of the ocean. It was a revolutionary achievement, unifying the celestial and terrestrial worlds under a single set of mathematical laws. But here's the thing. The Principia is a product of its time. Newton was writing in an era before the conventions and notations we use today were established. His arguments are geometric, not algebraic. He uses a form of calculus he invented himself, which he called fluxions, but he doesn't use it in the Principia because he feared the mathematical rigor would be questioned. Instead, he translates his work back into the language of ancient Greek geometry, a method that, while elegant, is incredibly difficult for modern readers to follow. Imagine trying to read a legal document from the 17th century. The language is archaic, the sentence structure is convoluted, and the concepts are rooted in a world that no longer exists in the same way. That's a bit like trying to read the Principia as a beginner. It's a historical artifact, a testament to the power of a single mind, but it's not a textbook. It's not designed to teach you. It's designed to prove a point to a small group of learned contemporaries who were already well versed in the philosophical and mathematical debates of the day. So, if you pick up the Principia expecting a clear, step-by-step introduction to physics, you will be sorely disappointed. You'll likely be confused, frustrated, and you will probably walk away thinking physics is an impenetrable subject. This is why many people, from seasoned physicists to history enthusiasts, will tell you that it's a terrible starting point. But the question isn't just about the Principia. It's about Newton himself, and the entire framework of Newtonian physics. Isn't that the foundation of everything? Shouldn't we start there? Well, yes and no. Newtonian mechanics is absolutely the foundation of classical physics. His 3 laws of motion are the first things you learn for a reason. Newton's first law, an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This is the law of inertia. It's simple, intuitive, and a powerful concept that shattered the Aristotelian notion that things had a natural state of rest. Newton's second law, the acceleration of an object is dependent upon 2 variables, the net force acting upon the object and the mass of the object. We all know this as the famous equation, F equals ma. It's the mathematical heart of classical mechanics. It quantifies the relationship between force, mass, and acceleration. Newton's third law, for every action, there is an equal and opposite reaction. This is the law that explains why a rocket can propel itself into space by pushing against its own exhaust. It's about the interaction of forces. These laws, in their modern, distilled form, are fantastic for beginners. They provide a simple, powerful model for understanding the world around us. And when you combine them with his law of universal gravitation, F equals G, M. 1. M. 2. /R. 2. You can explain so much of what we see, from why an apple falls from a tree to why the moon orbits the Earth. This is the Newton that beginners should start with. Not the historical Newton of the Principia, but the modernized, pedagogically sound Newton of a high school or introductory college physics textbook. These textbooks take the core ideas of Newton and present them in a way that is clear, concise, and easy to understand. They use modern algebraic notation, they provide worked examples, and they build a logical progression of ideas that make sense to a 21st century learner. But this brings up a deeper point. Why is it so much easier to learn from a modern textbook than from the original source material? Part of it is the language and notation, as we've already discussed. But another part is the centuries of refinement that have occurred since Newton's time. Science, and the way we teach it, doesn't stand still. We've had hundreds of years to figure out the best way to explain these concepts. We've developed more effective teaching methods, more powerful mathematical tools, and a more comprehensive understanding of the universe. For example, Newton's work was the culmination of a long process of scientific discovery. He built on the work of giants like Galileo and Kepler. A good beginner's course in physics doesn't just drop you into Newton's world. It often starts with the pre-Newtonian view of the cosmos, the Aristotelian model, and then shows how thinkers like Galileo began to challenge those ideas through observation and experiment. This provides crucial context and makes Newton's genius even more apparent. You understand not just what he discovered, but why it was so revolutionary. A beginner's journey into physics should be like climbing a ladder, one rung at a time. Newton's modernized laws are the perfect first rungs. You learn about force, mass, and acceleration. You learn about gravity. You solve problems involving inclined planes and projectiles. This builds a solid foundation of intuition and problem-solving skills. Then, you can move on to more complex topics. You can explore the limitations of Newton's laws. What happens when an object moves at a significant fraction of the speed of light? Newton's laws break down. This is where you introduce Einstein and special relativity. What happens when you look at the subatomic world of particles? Newton's laws are not enough. This is where you introduce quantum mechanics. This structured approach allows a beginner to build a mental model of the universe, starting with the classical, macroscopic world and then gradually expanding to the more exotic and counterintuitive realms of modern physics. If you start with the Principia, you miss this progression. You're trying to build a complex structure on an ancient, unrenovated foundation, and it's just not practical. With that said, thanks for watching and until next time.